Hello everyone, today I'll going to deliver a lecture on soil settlement. So there is a division. First of all, I'll discuss on the theory of settlement. There are three type of settlement. Total settlement is immediate settlement, which is occurred on sand, and primary settlement, which is occurred on clay, and secondary settlement, which is occurred on clay. And immediate settlement of or elastic settlement. Second, and then third part is consider settlement on clay of shallow foundation, which is isolated from the mat footing, and elastic settlement of group I, and consolidated settlement of group I. So in this portion, the lecture, the part 3 is very important. It is occurred immediately. So let's start the first of theory of the settlement. Okay, let's see. Here is a introduction of the settlement. We have been seen here. The stress is caused by the construction foundation is other load impressed by the soil. So deformation of soil particle, relocation of the soil particle, and explosion of the water. So the foundation settlement can be divided into three basic equation types, which is rigid or uniform settlement, or tilting or tripping settlement, and distorting and deformation settlement. So you can see here the uniform settlement, which is settled in the vertically on the, and second one we can see here, the tilting is occurred in rotating, and third one we can see the differential settlement, which is occurred in the one portion of the right side. We can see another example of the settlement. Tilting is here, and crack due to the distortion of the soil. Sir, we can see the total settlement will be immediate or elastic settlement, and primary consolidation settlement, and secondary consolidation settlement. Okay, so in this portion, our focus will be secondary consolidation settlement, which is SC and SS. Okay. So let's see the immediate or elastic settlement. We can see some definition. You may see elastic settlement is the theory of elasticity. On the other hand, primary consolidation is a saturated cohesive soil, which is the clay, and explosion of the water occupying the void space. This is the void phase of the primary consolidation. And secondary consolidation is occurred the observed the saturation cohesive that means clay, and the result of the plastic adjustment of the soil fabrics. This is the adjustment of the soil fabrics. You can see here the type of settlement in different soil, rock, gravel, sand. So in this way, there is immediate settlement is occurred all type of soil type. On the other hand, the consolidation settlement is occurred, there is no consolidation settlement, rock, gravel, and sand. So you can see here. And the other soil type is in silt, clay, and organic soil, which is the occurs the consolidation settlement. In the world, there is a two type of soil is available, which is sand and clay. So sand, the consolidation settlement is not occurred, and clay, which is consolidation settlement, is occurred. Okay, let's see. Here is some definition or immediate settlement. Here the flexible, if the flexible pavement, the settlement curve will be like this. On the rigid pavement, the settlement curve will be like this. In the same thing is here. So you can now the theory part is ended. So now we'll see the immediate or elastic settlement of sand or shallow foundation using the elastic theory method. So let's see here. This is the immediate settlement of clay and sand. The elastic theory method we have been using here. We can see here this immediate settlement. Sigma naught is the knot pressure settlement. B is a width of foundation and Poisson's ratio, elastic modulus of elasticity, and IP is a non-dimensional influence factor. So you can see this is the IP. So how we get the IP? IP is nothing but this equation 1 into m1 ln plus root over m square plus 1 divided by m plus ln m1 plus root over m plus m. What is m? M is the length of footing divided by width of footing. This is the V into L. So in this way we will found if the m be into what is m? M we have been seen here the ratio between length of footing divided by m and footing. If the ratio is 1.5, then IP influence factor of foundation will be 1.36, and if the m ratio is 2, then IP will be 1.356. And the representative of modulus of elasticity we have been found hardy soil and loose soil, which is 600, and loose soil 140 and dense soil to the 35000, and the Poisson's ratio we will found the loose and as will 0.0 to 0.4, and medium soil 0.25 0.40. So this is the formula, and this is the elastic theory. Now we'll see the example of the determine the elastic settlement. So determine the elastic settlement of the center of the footing is shown here in the following figure. In the construct of the saturated in clay, so this is the clay and the footing is flexible. We can see here the 2 meter and 2 meter, and vertical load is 500, and we'll use force into area, which is stress. Force is given here 500, area is 2 into 4, so we have a use here and found here. And when L by B, B is given, L is given, L is 4 and B is 4, so and found the ratio M is 2, then IP will be 1.56. How we'll get this from the chart. When 2, then we found IP equal to 1.56. So using this all the value here, and found the immediate settlement is 19.05. So we can see here another improved immediate settlement is given, Milo and Paulo. So they are B equal to root over P BL into pi, and B equal to footing length, and L equal to dimension. B is the diameter of footing. We have been known here as a improved relation Milo and Paulos in given by 1999. So let's see, this is the change of influence factor of variation ES, which is IG, IP, IE, and in the previous method we have been seen I is taken, IP is taken here, IP is taken from chart. This is the chart taken from chart with respect to the ratio of M. Now we'll seeing the another method which is different IG, IP, and IP. This is the value of beta, which is depend on E naught divided by K into B, and found IG. And same way IP will found this equation, and I equal to found this equation, and KF equal to found this chart. IP will do found this chart with respect to KF, and IE equal to found this graph with respect to DF BF. And now let's see the example for the shallow foundation shown below the figure. Determine the immediate settlement. Now we'll calculate the immediate settlement, which is given all the value, and B equal to putting here, and del C beta is 0.70, H equal to 1.5. When beta equal to 0.70 and H divided by B is 1.51, then IG equal to 0.7. 7 into 1.5, 7 into 1.5. Now we'll see the graph. 7 which is layer, and 1.5, this is the 1.5, and found for IG equal to 0.7, like this. Okay, so let's see, this is taken from graph, and another one IP equal to found calculating from here, and I equal to from here. And as we'll use the wall value influence factor value, and putting on this value, and found the settlement 27.5. And now we'll see the immediate settlement from Tarjugi and Peak and Hanson with respect to the SPT value. Okay, this is the equation, and CW is a groundwater table, CT is a correlation depth, and DF equal depth of embedded, and Q equal to bearing pressure, and B equal to foundation, and 60 SPT value. So we can see Tarjugi is given here, when H equal to less than B, then we equal to CW equal to 200, H is equal to greater than 2B, then we will use CW equal to 1. So let's see another, this is the Mayer-Rov correlation with SPT value. Mayer-Rov is given this equation when B equal to less than 1.25, when B equal to greater than 1.25, we will use this equation. So let's see an example. Determine the immediate settlement of the foundation is showing, given figure is given here, vertical load is given, and DF equal to N, and all the depth and SPT value is given here. So at first I will use the Tarjugi and Peak Hanson relation, and we will use all this value Q, and found settlement is found 6.04. Now we will use the Mayer-Rov correlation, and found 4.04. But what you can ask, which method we will use. I personally suggest the Mayer-Rov use, because the maximum settlement is given, found is here. So so these are the immediate settlement or elastic settlement is completed. Now we'll see the consolidation settlement. Okay, sorry, Now we'll see the consolidation part 3, consolidation settlement of shallow foundation of isolated footing. So let's see, this is the very important for the calculation. Now we'll see the primary consolidation, the normal consolidation is given here. We can see here the formula sigma naught, and when the overversion over consolidation clay, then we'll use this one, sigma naught into delta sigma is less than pre-consolidation, then we will use this. When sigma naught and delta sigma is greater than pre-consolidation, then we will use this. Basically this is this formula we have been already shown. I will calculate this this condition, and this condition, and calculating and the quick calculation for this MB, and we show CS equal to CS divided by, and CS equal to in this way we can use this formula. Okay, let's see another example. Here the primary consolidation clay, we can see CC and CS with respect to the void ratio and Q and compression index. So we can see the correlation and compression index CC is a very different many of the formula is given, but we will use CC, which is 0.00009 liquid limits minus 10, which is keep it on 1941 is given for an undisturbed clay soil. So let's see the Shawling index. We have been seeing 1 by 5 to 1 by 10, but we will use 1 by 10. So let's see. Let's see an example. The calculate the settlement 3 meter clay log and the load carrying is 2 meter is footing as shown. The clay layer is normally considered. So this is sand layer, this is sand layer, but we will use the we will calculate the clay layer settlement. So vertical load is given 1500. So let's see. At first we will use the sigma naught, which is gamma into H, gamma prime into H, gamma equal to 16. We have been seeing 16 into 3 and 19. This layer is 19 minus 9.81. This is the 19 is given here, and first of 16 into 3 and 19 minus 9.81, because this is the groundwater. 9.81 is the unit weight of water minus into 3, and clay layer into 18 minus 9.81 into 3. So 18 minus 9.81 into 3 and divided by 2. Divided by 2 means half. Why? Because the stress distribution way. We can use the stress distribution of 2:1 distribution, and sigma naught equal to vertical load into B plus Z into 2 plus Z. B is 2 and L into 2, and Z equal to 6. Okay. Now we'll putting all this value and found 41 millimeter. So let's see another example. So this is the example we've been seeing here. They calculate the settlement of the clay layer 3 meter thick and clay layer, and that will be result from the load carrying 2 into 3 footing as shown the figure below. The clay layer is normally consolidated and stress distribution is 2:1. So you can see what the data is given. The stress distribution on is 2:1. Then we will use this. I will get the Z value. Z value is nothing but minus 1.5. 1.5 is the depth of footing, and minus into layer of 3 plus 3, and second layer is 4, and third layer is 6, and divided by 2. Why? Because we will use will calculate the settlement of this layer, and putting this value and found the delta sigma and vertical effective soil pressure at the clay layer sigma gamma prime into H, which is 16 into 3 19.81 minus 9.8 into 4, and in this way found 6 by 2. Why we'll use the last layer 6 by 2? Because we will find the settlement at the middle of the CG of the middle. And using the consolidation settlement, this is the important why you will A is equal to 6, because we will use the clay layer settlement. That's why we will use A is equal to 6, and found 414 millimeter. Okay, let's see another example. Here the calculate the settlement of the footing diameter is given, and the primary due to the primary consolidation settlement of the soil use the 2:1 pressure distribution. So we have to use 2:1 pressure distribution distribution and depth of the fuel foundation is given. At first we have been seen sigma naught and sigma 1 sigma 2 delta sigma is 6.5, and we've been seeing the sigma plus sigma dot and settlement is here. So we have been seeing the layer is given here h 4 minus 1 into 1 layer 1 layer 2 consequently layer 1, and h is given from strip of 14.5 1.5 2.5 3.5. And how will the sigma naught into gamma into h equal to is varying 1.5 0.5 1.5 2.5, and z is the strip middle of the footing of the bottom, which is 6 into 0.5. 0.5 is given h, and 6 into 1.5 and 6 into 2.5 consequently. And delta sigma we have been found the variation will be changed equal to z, that's why it will be delta sigma to z. Sigma plus delta sigma is also here, and pre-consolidation is given 283. Okay, so now we'll see the status, which is normal concentration, over concentrated or normal concentration. We have been seeing some of the normal over concentration and some of the normal concentration, and when finally we'll calculate the settlement, and the total settlement will be summation and found 100 millimeter, which is 3.95 millimeter. So let's see another example. This is also going on the consolidation settlement. Okay, so they estimate the consolidation settlement of the foundation given below, and the dimension of the footing is 30 meter into 40 meter, and total load is 58 into 10 to the power 4 kilometer, and free consolidation is given 1049, and depth of foundation 3.5, and calculate the performance of the strip on subgrade. Okay, let's see. Sigma naught is here, and sigma 1 sigma 2 and z. I will get the z minus 3. Why? Because the depth of footing and 8 which is the first layer 8.5 plus 12.5 plus 5, and found 18, and this is the sand layer. So we can see here the variation of h layer for always we'll take the always 1 meter strip, and h is the midpoint of the strip, which is 0.5 1.5 2.5 and 3.5, and sigma dot equal to gamma into h, which is h is mid of the each of the layer, and z is found 70.5 into 0.5 and plus 1.5 into 2.5 and 3.5, and delta sigma into 208 and 201 19.3, and in this way sigma plus delta sigma pre-consolidation we have been seeing the pre-consolidation given 1058 which is given, and normal consolidation and over consolidation status is given here, and finally we will calculate the settlement. Okay, so I think the consolidation settlement has over. Now we'll see the elastic settlement of the group pile. So let's see the elastic settlement of the group pile. So this is the individual pile, so we will not see the individual pile, we will see the group pile. Okay, this is the elastic settlement of the group pile. This is the minor, because we are focusing the consolidation of the settlement of the group pile, but we have seen what's still happening the elastic settlement of the group pile. So this is the elastic settlement of group pile. The equation is given here, s equal to root over b into g, and b is equal to s equal to elastic settlement of group pile, b equal to depth width of the group pile section, and d is the diameter of the each pile group, and s is the elastic settlement we've been seen already. So this is the first example of the elastic settlement of the group pile. For the pile group is shown in the follow. The bigger estimate the elastic settlement, and the working load is the pile is vertical load is given 4000 kN, and the skin friction of the individual group pile is 250 kN, and the rest of pile is bearing. So we can see here is the 12 pile, and this is the all parameter is given here. So we are putting on this value and found E1 elastic settlement of the group pile individual one, E1 is 1.18, and in the same way we will found E2 and 11.39 in the and the individual elastic is in 3 is 0.69. And now we'll adding all three and found 13.23 millimeter for individual pile. Now we'll see the what will happen. It will, if the action is group pile, which is BG 3 into we know the 1 2 3 3 into 1 0.5 and 2, which is 1 and 2 is 1.5 and found 4.5, and the settlement is found 39.79. So the group pile is 39.75. On the other hand, we found the individual settlement, individual pile is found 13.26. So you can ask me which one we'll use. So we'll use the pile group settlement, as we want to stay the safe zone. So let's see here, this is the elastic settlement of group pile, this is the indet. Now we'll see the consolidation settlement of the group pile. So let's see, as a consolidation of group pile settlement, you can see here you have to must be use the 2:1 equation. Before we going to the 2:1 equation, we are limit the length of from where we will start 2:1. This is the formula 2 by 3 into L. It is taken from various code like SC7, SC318 or BNPC or like other courses. So let's see the example. Determine the consolidation settlement of the pile group is shown in the following assumption. The layer is normally consolidation. You can see all the parameters given here. LGBG and n equal to number of pile, you can see here in x direction. Now we'll see there's 3 minus 1 into d. D is found and d is a dia is a 3. Okay, let's here is a stress distribution method 2:1. We have been used 2:1 for getting the z value and putting a calculation for layer 1 and found the settlement which is 77.8, and in this way for layer 2 we have been found the settlement 39.6, and the last one, and for layer 3 have been found settlement 3.36. and now we'll adding all three value and found 120 millimeters settlement. Okay, let's see another example. This is the example. You can see here, they calculate the primary consolidation settlement of the soft clay of group piles in 9 pile of the soil profile is given below, and the length of pile is 15 and pile diameter is 0.80 and group pile depth is d. So b equal to 0.8. Here is a 0.8 into 0.8 and found 1.6. L we have been found 0.8 into 0.8, which is 1.6. and stress distribution should be started from 2/3 into L. This is the total length. We have been found 2/3 into L, that means 10. So stress distribution will be calculated. This stress distribution will from 10 meter. Okay, so we know the delta sigma equal to P into B plus Z into L plus Z. So Z we have been already calculated here, and sigma 1 and sigma 2 in found, and S equal to AC into MB into delta sigma. M equal to we have been taken 0.01 percent, which is 0.0001, but we can calculate M equal to from this portion, M equal to QB equal to 1 plus E naught, or MB equal to delta sigma equal to delta E into 1 plus E, or other formula. We can use this formula for taking for getting the value of M naught, and found 12.7 inch or 323 millimeter. Okay, so let's see another example. Here is another example of settlement of the group pile. We have been seen here. They calculate the consolidation settlement of 12 pile group consisting 10 meter long, and the bearing piles are that 80 centimeter diameter, and space is 2 meter center to center and each direction. Pile group carries vertical load is 5000 kN, and including weight of the pile cap, and use the 2:1 pressure distribution, and individual pile layer are two layer of the pile. Okay, so we can see depth is found was 10. How we'll get 2 into 3? We have been seeing here. The stress distribution begin. It will be begin bottom of the pile in the stiff clay. In case of the soft clay, distribution should be started. So it will be started 2/3 of L. L is the length, so 2/3 of L. This is the 10. So from this point we will be start the stress distribution cut, and sigma 1 we have been found, and sigma 2 we have been found, and as settlement we have been found 2.20 centimeter 2.20 centimeter square. So let's see another example. This is the group file of the profile of data is given below. Calculate the settlement of the soil sand for sand region, for silty sand and cohesion saturated sand. Okay, so we can see here the pile die is given 3, and pile length is 15, and pile length is 9, and capacity is given, and 60 is 50, and center to center distance of pile is 90. So B is given, M prime T is given 100, and N60 is given, and we have been PF equal to group load divided by group area. We have been for 9.95, and IF equal to 1 minus D by 8 into B, and found this is are not greater than 0.334. That's why we will use IF equal to 0.50, and settlement for sand. So this is for sand, and putting all this group we have found 1.70. For silty sand we have been found this equation, using this equation, and found 3.46. And another the settlement for cohesion less saturated clay, and for group pile we have been found 1.39. So how we can see here the silty sand is given the maximum settlement, and the lowest settlement we have been found the sand 1.774. Okay, so let's see another example. Here is a group pile of clay. Soil profile is given below. Calculate the settlement of the group pair in clay soil at the depth of 100 meter. So we can see here sigma vertical we have been calculated, gamma into H, and 4560. We have to define sigma naught by 2:1 method, which is Z. We have been found Z2 3 into H, which is 67 feet. So we have been found sigma naught is 67. So now we will calculate sigma B is greater than sigma P, and sigma B plus sigma C which is greater than also pre-consideration. So we will use CC will be used. So CC we know 0.009 liquid limit minus 10, and found 27 E not equal to 27, S equal to 5011 clay layer 2, and settlement of the clay layer we use this formula, and found 2.56 millimeter. Okay. So our consolidation settlement has ended. Now we will see the some extra math. So let's see. This is the extra math. So in this extra math we will see we will find out the length of pile. Okay. So let's see. They calculate the length of drill shape. Drill shape means the bore pile of the cohesive soil, and lateral load is given 100 kip, and the moment is 200 kip feet. Calculate the cohesive soil has undrained shear strength is 515 psi, and lateral shaft is 48, and use the Brom's method to calculate the length. So we have been seeing all the data. P is P, M, T, S, U, B is given, and F is found 15.43, and M T equal to using this formula, and found 32727 kip inch square, and G is found 142 inch square, and length we've been putting on this value 1.5 BB plus F plus G, and found 229 inch square, which is 19 feet. Okay, so let's see another example. Here is a better pile. So you can see the better pile. Here is the better pile. So you can see how we calculate the one of the leg of the steel resists the concrete pedestal footing, which is supported by the group pile of 18 piles. Outside of row inform the better piles is 1 to 4, and shown below. Each pile is permitted to resist horizontal load force is 25 kN, and calculate the axial load of all piles. And second one, put the unbalanced horizontal force is overcome. And third one is the allowing bearing capacity single pile is equal to 600 kilonewton, and state whether or not this pile is foundation is safe or not. So you can see here is the pile footing. So this is the pile arrangement. So we can calculate m and I is here, and q equal to q divided by n equal plus minus m equal to I into xi, and putting qi equal to 192, q2 242, and qc 333, and qd equal to 418, and q equal to 475. So maximum Q is found 475, and the axial load to in found 10 alpha into 1 by 4 and found 0.97. In this way we will found the axial load P1 equal to 198, and P2 equal to 248, and PC equal to 333 kilonewton, and PD equal to 418, and last one in PE equal to 490 kilonewton. So maximum load is found PE. So unbalanced horizontal force H equal to found 317 kilonewton. So available horizontal resistance we can see here 409 kilonewton, since it is the greater than HU, which is 317, and it is the greater than H is the resisting, H is greater than, and HU unbalanced horizontal force. So the unbalanced horizontal force is overcome. So maximum load is, we can see 498 is found PE, which is less than P overall 600. The foundation is safe. So we can see another example here, interpretation of the pile load test. We can see the question is the load settlement is shown figure, and the obtain the full scale load 400 square and 17 meter long concrete pile is 28 days compressive strength is 40, and use the Davison's method to compute the ultimate downward load capacity. You can see here the applied load. We have to calculate the applied load from this equation. So we have to calculate the settlement, and then drawing this curve, and in this way will intersect this one, then we'll find out the how many load we have to calculate. The Davison's method for the ultimate capacity as that which is occurred at the settlement 0.001 BR plus 0.1 B divided by BR plus PL divided by IE. The last term of the uniform formula elastic compression pile that has no confusion. So B is the diameter of the pile, and BR is the reference width, which is 300. P is applied to L is the length of pile. A is the cross sectional area of the pile, is the modulus of elasticity pile. We have been found is here, and settlement equation we have been used this equation and found 3.7 millimeter 0.005. So this is the settlement 3.7 millimeter. So this is the 3.7 millimeter. We have been found the settlement, and we'll draw the 1 is to 0.003. This is the line of the draw 1 divided by 3, and intersect this portion, and this and then we'll draw the upward in the horizontal in the vertical direction, and found 1380 kilonewton. So this load is needed for applying load is needed. So plotting this line of the load distribution curve and plotting P ultimate 1380 meter. So now pile driven energy correction. So we can see here another question 400 per square meter pile to be driven depth 12.5 meter. What should be the stroke or 1.5 ton due to the Danish formula? If the amount of penetration should be 5 millimeter per blow, the safe working load 2000 kilonewton on the pile. So if modulus of concrete is given 13 into 10 to the 6 kilonewton per meter square. So solution, we can see a pile is area is given 0.1 square, which is 0.16 meter square. So Q equal to root over QR into S divided by S into 0.5 into C2 into C2 equal to, we have been found 2 into root over SR W R S into L A into E, and putting all this value and found C2 equal to this formula. Now we'll this is the main formula. So now we'll putting all this value Q equal to known the q value is the load is given 200, so we're putting the q value, and the we are using the c2 values here and putting in here and found the h value. So stroke is 1.5 5 meter. Okay, so the lecture is in depth. If you have any question, let me know. So these are the syllabus. But one thing that the consolidation settlement of clay shell on clay consolidation of the settlement which is occur in clay. This is the very important rather than other groups. So if you have any question, then let me know. Thank you everyone.